So welcome back to the video. In this video we are going to study about OSPF, which is called Open Shortest Path First Algorithm. So this is the part 1. So previously we have seen about dynamic routing protocol, which has two types, that is IGP and EGP. So IGP has two algorithms, that is distance vector and link state, and then previous video we saw about routing information protocol. In this video we are going to study about the link state algorithm, and the protocol which we are learning is like open shortest path first. So let's take a recap of like link state routing protocol. So when using a link state routing protocol, every router creates a connectivity map on the network. So to allow each router each router advertises information about its interfaces to its neighbors. So these advertisements are being passed along the other routers until all the router form a network map of the same network. So I'll just share an example further, it will be clearer. So each router independently uses a map to calculate the best route to the destination. So link state protocol uses more resources, that is CPU, on the router because more information is shared. So however, link state routing protocol tends to be faster in reacting to the changes in the network than distance vector protocol, that is RIP. So its OSPF is better than RIP. So OSPF stands for open shortest path first, and then it uses an algorithm of Dutch computer scientist, that is Dijkstra's algorithm. Dijkstra algorithm is nothing but finding the shortest path between two points. So like it has three versions. Version 1 is not being used anymore, version 2 is used for IPv4, and version 3 is used for IPv6. So routers store information about the network in LSAs, which is link state advertisements, and then they advertise in the whole network, and then which are organized in a structure called LSDB, that is called link state database. So routers will flood LSAs until all the routers in the OSPF area develop the same map of the network, that is LSDB, in like all the routers, like it will form the network map. So let's take an example of LSA flooding, how it happens. We have taken 4 routers, 4 different areas, and then 4 routers again connected to 4 different areas. So OSPF is enabled on R4's G10 interface, that is G10 interface, and it has a network of 192.168.4.0/24, and then R4 creates an LSA, link state advertisement, to tell its neighbors about the network on G10 interface. So its neighbors is R2 and R3, and it creates an link state advertisement, that is the RID, which is called also router ID. The router ID is 4.4.4, and then IP is the network like which it has. So 192.168.4.0/24, and then cost is 1. So we have seen about the cost, like in dynamic routing protocol video previously we have seen like different routing protocol uses different metric, that is RIP uses hop count, OSPF uses cost. So and then to check the priority of which protocol is being used, it takes the help of administrative distance, that is in this case OSPF has an administrative distance of 110. So this LSAs is forwarded to the network until all the routers received it. So it is being spread over the network, and then this results in all routers sharing the same LSDB. So once everyone has LSA, it will form an LSDB, and then each router then uses the algorithm, shortest path first algorithm, to calculate the best route to the network on its interface. So how R2 will reach this network, it's like it will reach through G10 interface, like R3 will go through this, and then for R1 there is one path from here, like R2 to R4 and R3 to R4. So depending on the like the calculation it does in the network map, so it will take the shortest path and then reach the network on the router's interface. So each LSA has an aging time, that is 30 minutes by default. So the LSA will be flooded again after the time expires. So in OSPF there are 3 main steps in the process of sharing LSAs and determining the best route to the destination. So first is like it becomes neighbor with the other routers connected to the segment, and then it exchange LSAs as we saw before with the neighbor routers and then calculate the best route to each destination and insert them into the routing table. So just remember these 3 steps. If you are asked in an interview what is OSPF, how it works, so just tell these 3 things. Second, so let's see what are OSPF areas. So OSPF areas uses area to divide up the network. So small networks can be single area without any negative effect on the performance. So in this network you can see it is very small, like has 4 routers connected to 4 networks, and then it has 4 different networks on its interfaces. So but what about large area? In large areas, a single area network can have negative effects. So what are these negative effects? So the shortest SPF algorithm, shortest path first algorithm, takes more time to calculate routes, and then it requires more exponential, more processing power on the routers. So larger LSDB takes more memory on the routers, and then any small change in the network can cause router to flood LSAs and run the SPF algorithm again, and then spreading the LSAs to all the routers in the larger network can take more time. So just to avoid this, you just divide the OSPF network into smaller areas, and then let's take an example. So this is like a big large network over here, and then now I'll just divide into 4 different networks, that is area 0, area 1, area 2 and area 3. So there are some rules for this. So an area is a set of routers and links that share the same LSDB. So like this is like 4 different areas, and then each router will share like same LSDBs and LSAs. So the backbone area, area 0, is an area that all other areas must be connected to. So like this router should be all the routers over here should be connected to the backbone area. So you can see this router being connected to a area 1 router connected to area 2 router, that's not valid. So all the routers in the area should be connected to the backbone area. So routers with all interfaces in the same area are called internal routers. So like in area 1 this 3 routers, area 2 2 routers, area 3 3 routers. So who are inside the area are called internal routers, and then area routers with interfaces in multiple areas are called area border routers, that is ABRs. So see this routers, they have interfaces in area 1 and as well as area 0. So area boundary router maintains a separate LSDB for each area. So like on this side it will maintain for area 1 LSDB, and on here area 0 LSDB will be different. So it is recommended that you connect area boundary router to maximum of 2 areas. Connecting an ABR to 3 or more areas can overburden the router, so that or else it can have more processing power. So in order to just reduce it, just have maximum of like 2 areas. And then routers connected to the backbone area 0 are called backbone routers. So whatever routers are in the area 0 are called area backbone router. So an intra area route is the route to the destination inside the same OSPF area. So over here you can see inside the area, and then what is inter route, that is like in between the 2 OSPF areas. So I hope this OSPF link state protocol and OSPF in general is clear. So stay tuned for the next parts. I'll cover how the main functioning takes place, configuration in Cisco Packet Tracer, and then like I'll have 3 more parts. So that's all for this video. I hope OSPF is clear for you. So stay tuned for like further parts. Thank you.